In this problem, we have a 5 kg block sitting on top of a 10 kg block, and our goal is to find the force exerted by the 10 kg block on the 5 kg block and the force exerted by the 10 kg block on the surface. So as usual, we'll start by drawing our free body diagrams. So first, again, pause at this point, draw your two free body diagrams for the 5 kg and then for the 10 kg, and then come back and then we'll take it from there. So I'm assuming that you've paused, and I'm going to go ahead and draw the free body diagrams for the 5 and the 10. So I'm going to first draw it for the 5 kg block, and what we know is that for the 5 kg block we have the force of gravity pulling it down, which is equal to 49 newtons, and then we have the force of contact between the 10 kg block and the 5 kg block pushing it up. That's we're going to call that Fn1. And the reason I'm calling it Fn1 is because we have two surfaces, so we just do not want to confuse the forces. Now, let us draw the free body diagram for the 10 kg block. And what we have is for the 10 kg, we have its weight pushing it down, which is 98 newtons. Then we have the force of contact between the 10 kg and the surface pushing it up, which I'm going to call Fn2. Okay, and then the one thing that people seem to forget in this situation is that the 5 kg block also pushes down onto the 10 kg block with a force which is equal to Fn1, and that's why I've used the same colors for the two forces. Now we know that the acceleration is 0. Oops. And since the acceleration is 0, what we know is that the forces all have to balance out. So let us write the equation down for the 5 kg and then for the 10 kg. Once again, I would recommend that at this point you pause, write your equations, and then come back and check your work. Alright, so I'm going to go ahead and set up the equations. So for the 5 kg block, since the acceleration is 0, I know that Fn1 is equal to 49 newtons. Now you could have also written this as Fn1 minus 49 equal to 0. It would end up giving you the same thing. For the 10 kg block, we have Fn2 pointing up, and that has to be equal to Fn1 plus 98. And since Fn1 is equal to 49, I can write this as 49 plus 98, and when you add it all up, you get 147 newtons. Now, you may ask at this point, hey, what's the point of doing all the free body diagrams? We can just look at the situation and understand this. If you clearly you see that the 10 kg, the 5 kg sits on the 10, and so the 5 kg pushes down into the 10 with a force of 49 newtons. And therefore the 10 has to push back with the same amount of force. So that's easy. And then you can say, if you look at the surface of the table, then the total of 15 kg lies above it, and all that 15 kgs is going to push down onto the surface with 147 newtons, and that is exactly what we have. It'll all be correct, okay? However, when we have things that are accelerating, it is important to have the free body diagrams, and you'll see that, you know, the contact forces in those cases are not simply going to be equal to the weight. When things are at rest, it works this way. But it is not always going to be equal to the weight, as you'll see in the next problem that we solve. Alright, that's it for this one.